Wastewater math quiz number 5. All right, you know the drill. I don't own these questions. This is for educational purposes. You need a formula sheet, you need a calculator. First, I'm going to read the questions, then there's an answer slide. After that, I'm going to solve the questions and hopefully get the correct answers. Let's get to it. Question 1. A sludge pump has a bore of 6 inches and a stroke of 2.5 inches. If the pump operates at 55 strokes or revolutions per minute, how many gallons per minute are pumped? Assume the piston is 100% efficient and displaces 100% of its volume each stroke. A. 10.4 gallons per minute. B. 13.2 gallons per minute. C. 16.8 gallons per minute. Or D. 22.5 gallons per minute. Question 2. A screening pit has a capacity of 10 cubic yards available for screenings. If the plant removes an average of 2.3 cubic foot of screenings per day, in how many days will the pit be filled? A. 85 days. B. 105 days. C. 117 days. Or D. 135 days. Question 3. The flow to a secondary clarifier is 5.1 mgd. If the influent BOD concentration is 216 milligrams per liter and the effluent BOD concentration is 103 milligrams per liter, how many pounds per day BOD are removed daily? A. 3,945 pounds per day. B. 4,806 pounds per day. C. 5,227 pounds per day. Or D. 6,172 pounds per day. Question 4. Primary and thickened secondary sludges are to be mixed and sent to the digester. The 2,820 gallons per day primary sludge has a solids content of 5.7%, and the 4,650 gallons per day of thickened secondary sludge has a solids content of 3.6%. What would be the percent solids content of the mixed sludge? Assume both sludges weigh 8.34 pounds per gallon. A. 3.8%. B. 4.1%. C. 4.7%. Or D. 4.4%. Question 5. The amount of sludge to be dewatered by the belt press is 24,100 pounds per day. If the belt press is to be operated 14 hours each day, what should be the sludge feed rate in pounds per hour to the press? A. 1,721 pounds per hour. B. 1,642 pounds per hour. C. 1,535 pounds per hour. Or D. 1,815 pounds per hour. Here we have the answer key. Question 1, C. Question 2, C. Question 3, B. Question 4, D. Question 5, A. Next, let's solve these questions. All right, the first question was, a sludge pump has a bore of 6 inches and a stroke of 2.5 inches. If the pump operates at 55 strokes or revolutions per minute, how many GPM are pumped? We're assuming this is 100% efficient and displaces 100% of its volume each stroke. Well, to solve this, we need to solve for volume. Bore is the inner diameter of a cylinder, so we're going to use volume is equal to 0.785 times diameter squared, and it's going to be times the length times how many strokes per minute. So our formula sheet, this formula is solving for cubic feet, as most problems in water treatment math, whether it be drinking water or wastewater. So let's convert our inches into feet because we're solving for cubic feet. So 6 inches times 1 foot over 12 inches and 2.5 inches times 1 foot over 12 inches. So that conversion factor, it's division. All right, so you do the math and it cancels out your inches, and you're left with feet, so 0.5 feet and 0.208 feet. So we can plug those into our equation. All right, so we have 0.785 times 0.5 times itself squared times 0.208 feet times 55 strokes. Multiply across, and you get 2.245 cubic feet per minute. Now we need to convert this to gallons per minute. There are 7.48 gallons in a cubic foot. Cubic feet are going to go on the bottom, so they cancel out when you multiply. And you get an answer of 16.792, or C, 16.8 gallons per minute. Question 2 was, a screening pit has a capacity of 10 cubic yards available for screenings. If the plant removes an average of 2.3 cubic foot of screenings per day, how many days will it take to fill the pit? Well, first we need to find the capacity of the pit. We're going to convert cubic yards to cubic feet. So 1 yard cubed is equal to 27 cubic feet. So you're going to multiply 10 cubic yards. The cubic yard will go on the bottom, so it cancels out. So 10 times 27 cubic yards cancel out and leave you with 270 cubic feet. Total days, we have 270 cubic feet divided by 2.3 cubic feet per day. And the answer is 117.4, or the closest answer, C, 117 days. Question 3. The flow to a secondary clarifier is 5.1 mgd. If the influent BOD concentration is 216 milligrams per liter, that's supposed to be an L, not a 1, I apologize. And the effluent BOD concentration is 103 milligrams per liter. How many pounds per day of BOD are removed? And again, this is also an L per liter. Again, I apologize. So we have the pounds formula. We slightly modify it for this problem. So pounds is equal to capacity million gallons times concentration milligrams per liter times 8.34 pounds per gallon. All right, seeing what we were looking for is how many pounds per day are removed. We're going to do the influent BOD minus the effluent BOD. So that's our little modification to this pounds formula. So now we can plug everything in. Your flow of 5.1 million gallons a day times your influent of 216 minus your effluent of 103. And that's going to give you your removed milligrams per liter times 8.34 pounds per gallon. Let's do our subtraction first. 216 minus 103. You get 113 milligrams per liter of BOD removed. We want to find out how many pounds. So we're going to multiply that by 5.1 million gallons times 8.34 pounds per gallon. And the answer is 4,806, or B. Question 4. Primary and thickened secondary sludges are to be mixed and sent to the digester. The 2,820 gallons per day of primary sludge has a solids content of 5.7%, and 4,650 gallons per day of thickened sludge has a solids content of 3.6%. What would be the percent solids concentration of the mixed sludge? We're assuming that the weight is 8.34 pounds per gallon. Well, here's our formula for percent solids. It's going to be your total solids divided by your total volume times 8.34. All of this times 100. All right, to break that formula down even more, we're going to have gallons times the percent as a decimal times 8.34. That's going to be your primary sludge. And then you're going to add that to your secondary sludge, gallons times percent as a decimal times 8.34. And then you're going to divide that by the primary volume plus the secondary volume times 8.34. So we plug everything in, so you have the 2,820 gallons per day of primary sludge times 5.7 as a decimal, so 0.057 times 8.34. Then we're going to add that to the 4,650 gallons of the secondary sludge times 3.6 as a decimal, so 0.036 times 8.34. And then we're going to divide that by 2,820, the primary sludge volume, plus the 4,650 gallons of the secondary sludge volume times 8.34. So do your math in your brackets first. So do 2,820 times 0.057 times 8.34. You're going to do 4,650 times 0.036 times 8.34. And you're going to add 2,820 and 4,650. When you do your math in your brackets, you get 1,340.6 plus 1,396.1. We're going to divide that by 7,470 times 8.34. So go ahead and add the top together and then multiply the bottom. All right, so the answer would have been 2,736.7 on top and 62,299.8 on bottom. So you're going to divide that 2,736.7 by 62,299.8 and then multiply by 100. And you get an answer of 4.39, and that's going to round to your answer D, 4.4%. Question 5. The amount of sludge to be dewatered by the belt press is 24,100 pounds per day. If the belt press is to be operated 14 hours each day, what should be the sludge feed rate in pounds per hour to the press? To find the feed rate pounds per hour, we're going to take the total sludge pounds per day, and we're going to divide that by the operating hours in a day. So there's 24,100 pounds to be dewatered, and then 14 hours is how much time you're going to be operating the press. So you do your division, 24,100 pounds per day divided by 14 hours in a day. Your day is going to cancel out, leave you with pounds per hour. And the answer is 1,721.4. That's going to be A, 1,721 pounds per hour. So that's it. It's another 5-question wastewater treatment math quiz in the books or on the internet. Hopefully this is helping you study and learn. Thanks.